x-axis, no? Or 90 minus theta 1 with negative y-axis. How to manage this? Let's a bit. I'll change this one, so it'll be this one. Let me make it. Yeah, so somewhere here at this particular point A, the dipole moment, the electric field strength due to this dipole has to be determined. So where this will make an angle theta 2. How to manage this one? So I'll go for some other approach. What is that? Component of dipole moment along the R bar and component of dipole moment perpendicular to R bar. Even this approach also is going to help you a lot. So this is that line. So here, so what we do is like a one component of dipole moment will be there along this. P parallel, right? The other component, I'll assume it to be perpendicular to this. The dipole moment also we can resolve, not that only electric field. This angle, we know that this angle is how much? It was theta 1, theta 2, no? This is the reference line. So what is P parallel? The P parallel should be equal to P into cos theta 1 plus theta 2. P perpendicular will be P sine of theta 1 plus theta 2. Now at a distance R, here I want the field. So now due to P parallel, how it will be? Like it's as good as this is one dipole, this is one dipole, no? And the point A is here. Where the point A? Point A is on the axis of a dipole moment P parallel. Getting the method? Similarly, point A is now where? It is on the bisector of the dipole moment P perpendicular. And we know how to calculate the field. So this will be due to, let me write due to this, let me write E1. This will be E2. E parallel, E perpendicular, not due to one, due to this, or I think this will be more confusion for you. E dash, E double dash, I'll write. What is E dash? E dash is due to only P parallel at point A. What about E perpendicular? Like E double dash? E double dash is like a due to P perpendicular. So what are the values? E dash should be equal to 2P parallel 4 pi epsilon naught R cube. What about E double dash should be equal to only P perpendicular 4 pi epsilon naught R cube. What is the resultant E bar? Should be I think this will be much easier method, no? And substitute P parallel, P perpendicular with these values. So you can use any of the alternative methods available for you. Getting some, all these are skills. Now we know concept. All these are the skills. You can resolve even dipole moment also according to your requirement. Anybody having doubt, you can clarify. So why I'm discussing this problem? I just saw one numerical of this kind. There's a charge plus Q and is asking find the dipole moment somewhere here where this will make an angle theta, where this R is very much greater than, I'll write it. Now I think the approach what I given will really going to help you a lot. R very much greater than L. So you have to find out the field strength at point A. Tell me what you're going to do due to this point charges. What is the method? So first due to, okay sir, what I do is like due to this plus 2q charge, the field will be somewhere here. Due to positive charge will be here. Due to negative charge somewhere in this direction. Then I'll take the vector sum. Very, very lengthy. Instead, we can go for dipole moment concept because of this condition given. So here, what shall I do now? I'll treat this as one dipole. So there's one dipole is there of dipole moment LQ and the other dipole moment of L2Q. The resultant vector sum, I'll get it. Please do learn these methods. These are very important. Dipole is not just about the formulas. This is one dipole, P2. There's another dipole. I'll get P1. What is P1? P1 should be equal to L into 2Q. This minus 3Q charge, shall I break up? Minus 2Q plus 2Q minus Q and plus Q. And what about P2? Should be L into Q. The vector sum of this, how it will be? It should be near. Okay, let this make an angle alpha. So can we calculate the resultant dipole moment? P is equal to P1 square plus P2 square. That we got it. Can we get alpha? Tan alpha equal to P2 by P1. That should be equal to 2. Okay, I got the alpha. Now, where is the point? The point where is asking to calculate field. No, it is somewhere here. No. Again, what is your approach?
Tan alpha is 1/2.
Tan alpha?
P2 by P1 is 1/2.
1/2.
1/2, huh? Okay, 1/2. I'll make changes here. Yeah. Okay, I got alpha. So I'll give the value of theta. Now I want the field strength at point A. So tell me what shall I do? Again, I'm going to resolve P cos of theta minus alpha. The dipole moment of that will be along this R bar. P sine of theta minus alpha will be perpendicular to that. Then I'll get the fields. I'll take the vector sum. I'll get the resultant field. Or else calculate the angle between R bar and P bar. Substitute in that formula. Any of the approach. Able to make it out? I'm just sharing the idea. We'll take the next set of numericals.